Well, we've had a busy few weeks with our fractions, so I thought I'd just stop and take a moment to reflect on some of the fraction work we've done over the last few weeks, focusing in particular on adding and subtracting, and the slightly more difficult ones, which are where the denominators are different. So let's just take a look. We'll work through it gradually. There's a few little tasks for you to have a go at if you wish, but let's crack on. Okay, first of all, just a quick reminder of what a fraction actually is. Fraction is made up of two parts, two digits. We've got the top number, which is the numerator, the bottom number, the denominator. The denominator tells us how many equal parts something has been split into. So you can see up in the top left corner here, we've got a bar which has been split into 4 equal parts. 3 of them are shaded. There's our numerator. The numerator tells us how many parts we're interested in. How many parts have been shaded, how many parts have been eaten, how many parts have been taken away, whatever the question is asking you. Okay, so denominator, how many equal parts the whole has been split into. Numerator, how many parts we're interested in. Another way we can show a fraction is on a number line. So you can see here we've got 0 to 1 on our number line, and it's been split into 4 equal parts. So that would be 3 quarters shown on a number line. And then the pizza diagram, the circular diagram, you can see has been split into 4 equal pieces. 3 of them are shaded, 3 quarters. Okay, very, very basic stuff, just to remind ourselves what a fraction actually is and what the digits represent. Now, adding and subtracting when the numerators are the same is really, really straightforward. If we get questions where the denominators are the same, then we should be really, really pleased because they're nice and easy ones. Here we've got 1/5 plus 3/5, and because the denominators are the same, we're adding like with like, then all we need to do is add the numerators. 1 plus 3 is 4. So 1/5 plus 3/5 is 4/5. And here we can see it on our bar model. The bar model has been split into 5 equal parts, into fifths. There's the 1/5, there's 3 more. All together, 4 of them are shaded. Okay, now that only works when the denominator is the same. Similarly with subtraction, if the denominator is the same, we can think ourselves really, really lucky because this is going to be an easy question. We have got 4/5 here, and there's the 1/5 we're going to take away. So we're down to 3/5. 4 subtract 1 is 3. Yeah. And that only works because the denominators are the same. We are taking away like from like. So adding and subtracting fractions when the denominator is the same is quite simple. You just add or subtract the numerators and leave the denominators the same. Okay, that's highlighted here. We've got 3 apples plus 1 apple is 4 apples. We can do it because we're using the same units, in this case, apples. 3/6 plus 1/6 is 4/6. Okay, so as long as we are adding and subtracting like for like, the denominators are the same, it's very straightforward. But how do we add and subtract fractions when the denominators are actually different? First of all, we need to make the denominators the same. You can't do fraction addition or subtraction if the denominators are different. We need to do that conversion. We need to create equivalent fractions with the same denominators. So for this, we're going to be going back a few weeks and using our knowledge of equivalent fractions. Remember, whatever you do to the top, you do to the bottom. And as long as you follow that rule, you will always create an equivalent fraction. Now, there are 2 ways we can do our adds or subtractions when the denominators are different. So let's take a look at them. First of all, we might be lucky, okay? Because if we check whether one denominator is a factor of another, life is a little bit easier for us, okay? So we're looking to see if one of the denominators, in this case, the smaller one, the 5, will go into the larger one. And we can see that 5 does go into 10. It goes in 2 times. So if we multiply the 5 by 2, then we're going to get 10. And that helps us out with our knowledge of equivalence. So if we times the 5 by 2, we'll get 10. we must do the same thing to the top as well. Remember, whatever we do to the bottom, we do to the top. So if we multiply top and bottom by 2, you see, there's our equivalent rule, done the same thing top as we've done to the bottom one, then 2/5 becomes equivalent to 4/10. 2/5 and 4/10 are the same amount. If you ask for 2/5 of a pizza or 4/10 of a pizza, you're going to get the same amount of pizza. So all we've done there is change the digits to give us a 10 as our denominator. This allows us to do the addition. Okay, so 2/5 plus 3/10 is exactly the same as saying 4/10 plus 3/10. And now it's really straightforward. 4 plus 3 is 7. Okay, so 4/10 plus 3/10 is 7/10. Or going back to the original question, 2/5 plus 3/10 is 7/10. Okay, here's a few to have a look at. If we look at the smaller denominator in each of these, what do we need to do to it to turn it into the larger number, the larger denominator? Just take a moment and have a look. Okay, let's take a look then. To turn a 3 into 12, we're going to times by 4. But following the equivalence rule, we must do that to the top number as well, to the numerator. To turn a 5 into a 10, we're going to multiply by 2. Equivalence rule means we have to multiply the 4 by 2 as well. 6 to 18, we times by 3. And for it to be equivalent, we must times the numerator by 3 as well. And finally, 5 multiplied by 4 gets us to 20. We must do the same to the top number, to the numerator. Okay, let's work these through. So 2/3 multiplied by 4, top and bottom, becomes 8/12. 8/12, take away 4/12 is 4/12. Okay, so there's our answer. But some of you might have recognized that we can simplify this. We can divide both numbers by 4, giving us 1/3. Okay, 4/12 is a correct answer, unless you're asked to simplify, but 1/3 is an even better answer. What about this addition here? So 4/5, we've decided we're going to multiply top and bottom by 2. So 4/5 is equivalent to 8/10. So now we've got 8/10 plus 1/10 is 9/10. 5/6, we realized if we multiply by 3, top and bottom, we would get a common denominator. So 6 times 3 is 18, 5 times 3 is 15. So 5/6 is equivalent to 15/18. 15/18 plus 1/18 is 16/18. And we can simplify this a little bit by dividing top and bottom by 2 to give 8/9. And finally, 4/5 is equivalent to 16/20 because we've times top and bottom by 4. So 4/5 is equivalent to 16/20, and 16/20 take away 5/20 leaves us with 11/20. Okay, I went through that quite quickly, so feel free to rewind and review the clip at any point. Here's a few for you to try. So if you want to have a go at these, just pause the video at this point and work them through. Okay, but I'm going to press on. Now, sometimes the denominators are not particularly nice and they're not factors of each other. So we actually need to convert both of the fractions in the calculation to create that common denominator, a number that they both go into. Here's an example, 1/6 add 3/10. Now 6 doesn't go into 10, so we're going to have to find a number that both 6 and 10 go into. So at the bottom here, I've written out the first few multiples of 6. So we've got 6, 12, 18, 24, 30, 36, 42, 48. Numbers we should all be familiar with because we're learning our tables, aren't we? And then the 10 times table, 10, 20, 30, 40, 50, 60, and so on. The first number that both 6 and 10 are factors of is 30. Okay, so we now know what our common denominator needs to be. And the next trick is to convert, using our equivalence rule, convert 1/6 to 30ths and 3/10 to 30ths. And here's how we're going to do it. The 6, to turn 6 into 30, we need to times by 5. And we do the same to the numerator. So 1/6 is equivalent to 5 30ths. To turn tenths into 30ths, we're going to times by 3 and do the same to the top. So 3/10 is equivalent to 9 30ths. We then simply add. We've got our common denominator. Both our fractions are 30ths. So all we need to do is add the numerator. 5 plus 9 is 14. So 5 30ths plus 9 30ths is 14 30ths. And you might have spotted we can divide by 2 and make that a little bit tidier at 7 15ths. Okay, so 1/6 plus 3/10 equals 7 15ths. Again, a few for you to try. Pause the video and have a go at these. I'm going to press on. Now, even with mixed numbers, you need to find a common denominator. It is so important. Without that common denominator, without the fractions having the same denominator, you cannot do the calculation. Okay, but how you approach this, there are 2 different ways, and it's up to you. It's whichever you prefer. The first option is to add the whole numbers and then deal with the fractions. So in this particular example, we have got 2 1/5 plus 4 3/8. First of all, we're going to deal with the whole numbers. 2 plus 4 equals 6. Simple enough. Now we're going to deal with the fractions. 1/5 plus 3/8. Now we need to create that common denominator. And I've decided that I'm going to go with 40. 40 is in the 5 times table. It's also in the 8 times table. So to turn my fifths into 40ths, I'm going to multiply by 8. 5 times 8 and 1 times 8. Always do the same operation, top and bottom. So 1/5 is equivalent to 8 over 40. 3 over 8, I'm going to multiply by 5 to turn it into 40. So 3/5, 3 times 5 is 15, 8 times 5 is 40. 3/8 is equivalent to 15 over 40. So I've now got 8 over 40 plus 15 over 40. I have got the same denominators, so I can do the calculation. 8 plus 15 is 23. And all I need to do now is bring these 2 answers together. The whole numbers made 6, the fractions made 23 over 40. Altogether, we have got 6 and 23 40ths. Okay, a little bit long-winded, but hopefully you can see where those numbers came from. The other option you've got is to convert your mixed number into improper fractions and then add the improper fractions. Now, sometimes this can create quite big numbers, which can be a little bit more scary, but it also can be another way to actually approach it. So up to you. Take a look and see what you think. First of all, we need to turn these mixed numbers into improper fractions. Now, this is going back a few weeks, but remember how we do it? Whole number multiplied by denominator. So 2 times 5 is 10, plus the numerator gives us 11. So we've got 11 over 5. The denominator doesn't change. 4 times 8 is 32, plus the 3 is 35. So we've got 35 over 8. So we are adding 11 over 5 and 35 over 8. We still need to find that common denominator. We still need to find that the same denominator for both fractions, or we can't do it. So like last time, I'm going to multiply the fifths by 8. 5 times 8 and 11 times 8, which is going to give me 88 over 40. And then I'm going to multiply 35 by 5 and 8 by 5. There we go, 88 over 40 plus 175 over 40. As I said, sometimes this method can create quite big numbers. 88 plus 175, 263 over 40. Now that is a big, ugly, improper fraction. But if we simplify it, if we turn it into a mixed number, surprise, surprise, It's exactly the same as the previous method. 40 goes into 263 6 times with 23 left over. 6 and 23/40. Okay. The choice is yours. Similarly for subtraction, you can deal with the whole numbers and then the fractions, or turn it into an improper fraction. With subtraction, sometimes we need to be careful because the fraction alone might not be enough to be taken away from. So we need to do a little bit of converting. So whether we convert one of the whole numbers into a fraction, so one whole becomes, in this case, 5/5, or whether you convert the whole thing into an improper fraction. Okay, well worth a practice. Have a play around with it and feel free to rewatch any part of this video or any of the other flipped classrooms we have done. Please remember, guys, the flipped classrooms will never be deleted. All the ones from this year, all the lessons from last year during lockdown are still available for you to view. So if there's any part of the maths curriculum we've done so far that has not been clear, take the time to review it yourself, okay? We can't go over everything over and over again. If it's down to you guys to learn your tables, to learn the corresponding division facts, and to review some of these lessons. Okay. Good luck, and I'll see you during the week. Take care.